Alright guys, this is your tutorial for Wednesday, October 21st. Make sure you have clicked the attendance link and signed in for today so we can mark you present. A couple of reminders. We did our water cycle quiz on Monday. If you still have not completed that, please get it done. And also your water cycle vocab was due on Monday, so make sure you've got that turned in as well. Today you are going to be taking notes on weather. Remember that the highlighted word on the slide presentations will show you what word to put into the blank of your notes template. And then you'll need to submit that so that we can see that you guys are doing what you're supposed to be doing. You were assigned a new set of vocabulary, and that is due on Friday the 30th, so make sure you are being diligent and working on that throughout the week. So the notes we're taking today are on different weather factors. So these are factors that can affect the weather that occurs. We're going to start by talking about humidity. Humidity is the amount of water vapor in the air. So remember, water vapor is that gaseous form of water. So if it feels super humid out, that means that there's a lot of water vapor in the air. It feels really thick and moist and muggy. That's all because of humidity. Now we measure humidity using a psychrometer. How this tool works is you grab the stick and you sling it side to side. There are two little bulbs off of it. One bulb is called a wet bulb because it has a little piece of cotton that you dip in water. And then another bulb is called a dry bulb. When you sling it, they'll both read the temperature of the air, and then you'll subtract the difference in the temperatures, and that will give you the humidity in the air. Relative humidity is just the percentage of water vapor that's in the air versus that actual maximum 100% amount that the air can hold. And it's important to note that warm air can hold more water vapor than cold air can. And that's because with warm air, your molecules are more far apart, so you have all that space for water vapor to go into the air. Whereas when you have cold air, your molecules are super close together, so there's very little room for water vapor to go. Now, when we talked about the water cycle, we talked about condensation and how that was the stage when clouds formed, but we didn't really go into cloud formation. So we're going to talk about that in this set of notes. Clouds form whenever water vapor, so the gaseous form, condenses to form water or ice. So it's that conversion when it goes from gas back to liquid. Okay, so it was in a gas state because it was heated up, and when water is heated, it turns into a gas. But we know as you go up higher in the troposphere, it cools down. So it no longer stayed warm, and once it reached that temperature where it cooled down, that temperature is actually called the dew point, then condensation could occur. So what happens with condensation is all of those particles that are in the air, all the water vapor would do is find particles to condense on, and as it was condensing, it would build higher and higher, and it would form clouds. So that is how clouds are formed. And then if you look in this picture, it shows you that it starts with evaporation. That warm, moist air then cools down. It reaches that specific temperature where condensation can occur, which is called dew point, and then your clouds are formed. There's another picture here that shows you a visual of what I was talking about on the last slide about how cold air can't hold as much water vapor because those molecules are more tightly together, so there's less space for the water vapor to go. Whereas hot air has the molecules further apart, so there's lots of space for the water vapor to be. Now, talking about cloud formation, we're going to go into the different types of clouds. The first type of cloud we're going to talk about is a cirrus cloud. A cirrus cloud is like your thin, wispy cloud. I think these are all Latin terms for the clouds, and cirrus talks about like a thin wisp or curl of hair. That's where cirrus got its name. So these are your thin, wispy clouds, and they are actually made up of ice crystals. So they're not made up of just water. They are made up of ice crystals, and this is because they're so high up in the air. So a cirrus cloud is our high-level clouds, and they are so high up in the troposphere where it's so cold that when these clouds are formed, they're not formed by water. They're actually formed by ice crystals. Whenever you see cirrus clouds, this pretty much tells you that there's going to be fair, pleasant weather. These definitely do not indicate a storm or any type of threatening weather. Next, we have your cumulus cloud, which everybody knows. Your cumulus cloud is your typical puffy cotton ball white cloud, right? It's considered a low-level cloud. So if you look at this visual down here, up here is the cirrus cloud that we just talked about. and then down lower is your cumulus cloud, okay? Whenever you see cumulus clouds, these mean that there's going to be neutral or fair weather whenever they're found in the middle or lower altitudes. Now, there are clouds like the cumulonimbus cloud that when it builds up vertically, this is your storm cloud. But a basic, normal cumulus cloud that's low level, it's going to indicate clear or fair weather. The next type of cloud is a stratus cloud. A stratus cloud just lays and blankets over top of the sky, right? It's just this flat layer. It's gray in color. That typically lets you know that it's going to bring rain. And you can look in this generic picture here. You see that high-level cirrus cloud, low to mid-level cumulus cloud, and then beneath that is your blanketing stratus cloud. Now, whenever you throw different prefixes or suffixes in front of a cloud name or behind a cloud name, it means different things. So nimbo or nimbus means rain producing. A cumulus cloud means fair weather. Throw cumulonimbus together, and now you have a puffy cloud like the cumulus cloud, but now it's going to be bringing rain and storms, okay, because nimbus means rain producing. So you need to know that our cumulonimbus cloud is the storm cloud. So this is the cloud that brings storms. It's still puffy like a cumulus cloud, but it rises up vertically higher up in the atmosphere. If you throw the word alto in front of the cloud name, that means it's going to take that cloud just a little bit higher. So for example, here is your cumulus cloud, right? Low-level cloud. Throw the word alto in front of it, you still have a cumulus cloud, it's just a little bit higher up right here. Same thing for stratus. Here's your blanketing stratus cloud. Throw the word alto in front of it, it's going to be a stratus cloud, but a little bit higher up. In your notes, you need to look at this picture and label the blanks that are there to indicate which cloud is missing. All right, so let's talk about the different air masses. Whenever we look at weather, we look at air masses, we look at front, and we kind of see what's causing these different changes in our weather patterns. So an air mass is a huge body of air, right? And it has the same properties in it. So it has a similar temperature throughout the whole body of air. It has similar humidity throughout the whole body of air and similar air pressure, all right? If you have an air mass that collides with another air mass of different properties, that's going to create what we call a front. So let's talk about the 4 different types of air masses. You can have polar or tropical air masses, which deal with the temperature of the air in the air masses, or you can have a maritime or continental air mass, and that deals with the amount of humidity or moisture that's in the air mass. So polar air masses form either up top or down in the south where your poles are, so obviously they are bringing cold air. Tropical air masses form at the tropics, so when you think of someplace tropical, you should think of someplace warm. So tropical air masses bring warm air. And then you have your maritime air mass. Maritime is often used in ocean terms, so you should associate a maritime air mass as an air mass that forms over water. So if it's forming over the water, it's going to be a moist air mass because it has the ability to pull water vapor from that water source, and when it hits land or wherever it's going to be a moist body of air. A continental air mass is the opposite. It forms over the continent, so over the land. Because it doesn't have any water to pull from, it's a very dry air mass. So looking at this picture, you throw the words together to make different air masses. So you have to use a word that represents moisture, so maritime or continental, or a word that represents temperature, so tropical or polar. So you can have a maritime polar air mass, which means it forms in the ocean, it's moist because of maritime, and then it's bringing cold air because it formed at the poles. You can have a maritime tropical air mass forming in the ocean, being moist, and then forming near the tropics, so bringing warm air. There's a continental polar forming over the continent or the land, so it's dry, and it's forming at the poles, so it's cold. And then a continental tropical air mass. Continental, once again, forming over the continent or land, and it's going to be dry. And then if it formed at the tropics, it's going to be bringing warm air with it. So on your notes, you were supposed to indicate whether the air mass formed over land or water. So the first one was maritime polar. If it's maritime, it forms over the water. If it's continental, it forms over the land. So 1 and 2 both had the word maritime in it. So both of them formed over water. And then 3 and 4 both had continental in it, and the continent is land, so continental air masses form over land. Now, I mentioned that whenever you have two unlike air masses and they meet or they collide, that forms a front. So a front is defined as a boundary where two air masses meet. There are 4 types of fronts we go over. A cold front, a warm front, a stationary front, and an occluded front. And you can look at these pictures and see, just based off of the weather and the cloud formations, where the different air masses are hitting and causing a front. All right, so starting with a cold front. A cold front is whenever you have a really quick advancing cold air mass pushing in, and it pushes a warm air mass up and out of the way, okay? So a cold front moves very quickly. It's our quickest moving front. And if there's water vapor inside of that warm air mass, when that cold air hits it, it's going to create rain. Now, these fronts move so quickly that whenever it happens, it causes fast weather changes, specifically violent thunderstorms. So the majority of bad weather happens around a cold front, because whenever you have that cold air hitting that warm air so quickly, it causes the disturbance in the atmosphere, which is creating your storms. Now, whenever you see a front on a weather map, you see these little symbols. So this represents a cold front, the little triangles hanging off the line, okay? I always tell my kids to think of them as icicles hanging off the line to represent cold. And whichever direction the triangles are pointing shows you which way the front is moving. So this front would be moving south. Okay, and you see that after the front passes, you're going to have really cold weather. So a cold front brings cold weather behind it. Now, wherever it hits, you see these abrupt weather changes, and that's where your storms occur. All right, next is our warm front. And a warm front is a slower moving front. So this is not a quick moving front. And this is whenever warm air is now pushing in first, and it displaces the cold air. It moves up and pushes over it, okay? So whenever this happens, if there's lots of water vapor in that warm air mass, it can bring rain or clouds for a couple of days. And after it passes, you're going to have nice, warm, clear weather, right? It'll be a little humid because it's warm air, and we know warm air can hold more water vapor. So it will be humid. And then if you look for the map symbol, they look like little half suns on the horizon. That's what represents a warm front. Next, you have a stationary front, and that is a front that's not going to move. So you have a cold air mass, it hits a warm air mass, but instead of one pushing the other out of the way, they're in a standoff. They can't move each other. So if there's lots of water vapor in that warm air mass, it's going to bring rain for days until one air mass can push the other up and out of the way. Okay, so depending on the type or the amount of water vapor in the warm air mass depends on the type of weather that location is going to have for a long period of time until one air mass pushes the other one. To represent this on a map, you will see that there's a warm front on the opposite side of a cold front because they meet and can't push each other out of the way. The fourth type of front is an occluded front, and this is our most complex front because it involves 3 different air masses. You have 2 cold air masses with a warm air mass caught in between. Okay, it's almost like it's sandwiching the warm air mass. So you know with cold fronts, like these 2 things coming through right here, you know that they bring abrupt weather changes and they can bring thunderstorms. So an occluded front can bring thunderstorms, but most likely it's going to be more moderate to heavy rain with an occluded front. Now, whenever this happens, you will see your map symbol shows you have a cold with a warm sandwiched in between another cold. Okay, so you see your warm in the middle of 2 cold, and that would be your map symbol for the occluded front. Now, when we talk about pressure systems coming in and affecting the weather, we talk about cyclones and anticyclones. One represents low pressure and one represents high pressure. A cyclone represents a low pressure system, and it's a swirling center of low pressure. Cyclones bring bad weather. Good way to think of it is when you're feeling low, you're feeling bad, right? So low pressure equals bad weather. Cyclones cause clouds, winds, precipitations, all bad weather occurs around low pressure systems. Tornadoes, hurricanes, all low pressure systems, okay? And these form at frontal boundaries. So you see here, this would be a cyclone because you have your converging wind going up, making your clouds, causing precipitation and storms. The opposite of that is an anticyclone, which represents a high pressure system. So like when you're feeling like you're on a high, you're feeling good, right? So high pressure equals good weather. So an anticyclone is a high pressure system. It's surrounded by dry air, so you're going to see clear weather. Okay, you're not going to have a lot of water vapor or anything like that associated with a high pressure system. And these systems also form at frontal boundaries. So this is a nice visual that just kind of shows you the direction of the winds and what kind of weather it's producing. With an anticyclone, you just have sinking, diverging winds, so it's bringing calm, clear weather. And with converging winds here, with your hot air rising, it's going to be causing your clouds and your storms and your bad weather. So now let's talk about the different types of bad weather that could occur around our low pressure systems. So the first is a flood. Everybody knows that a flood occurs whenever you have a lot of water dumped in a short amount of time, okay? Causing either a river, a stream, some type of body of water to overflow and to rise on surfaces it doesn't normally rise on. A flash flood is whenever the flood happens in a flash, so too much rain dumped in a really short amount of time. Things we have put into place to help prevent damage from floods is we have advanced warning, so technology that lets us know ahead of time when to expect this kind of stuff. We also have dams and levees, which are all safety measures that are put into place to control flooding, so to prevent that excess water from flooding over. The opposite of a flood is a drought. So a drought is whenever we go a long period of time and we don't have hardly any rainfall. So typically caused by dry weather systems, so the ones that aren't dumping precipitation over us, and whenever they remain in a specific area for a long period of time without dropping precipitation, droughts occur. Whenever droughts occur, you want to make sure that you are conserving water because there hasn't been a lot of it in that area. Next, we have thunderstorms. Everybody knows that a thunderstorm brings thunder, rain, lightning, sometimes hail. You need to know that they form in large cumulonimbus clouds, that they're brief, they're intense, they occur over small areas, and then they move on, right? So the way that they form is whenever your warm air is forced really quickly up along a cold front, right? Because we said that cold front hits really hard and fast and it shoves the warm air up really quick. And when that happens, it forms a thunderhead or a cumulonimbus cloud that's bringing a storm. Characteristics of a thunderstorm are heavy rain, possible hail, strong upward and downward drafts for your winds, updrafts and downdrafts, and then also lightning and thunder. Next, we have tornadoes, which also develop in cumulonimbus clouds, but they start reaching down to the surface in a funnel shape. I dragged this picture onto the slide because this is a tornado that actually hit in North Carolina in Wilson. So I thought it was cool that it was relatable. So tornadoes form whenever a warm, humid air mass meets a dry, cold air mass. So two completely different air masses, right? Warm air is forced up along the cold front to produce several thunderstorms, which then can turn into tornadoes. This is your most damaging type of storm because they are not predictable. Like we can tell like when the situations may be right for a tornado to hit, but sometimes they spawn out and spout out and we weren't ready for that to happen. We didn't have advanced warning, right? So with tornadoes, they include your spiraling high winds. So this is your storm that has the highest winds and it's swirling around a low pressure area. And there's actually a specific area in the United States where we see a lot of tornadoes, and that's called Tornado Alley. And Tornado Alley is from central United States, from Texas to Nebraska, Iowa, that kind of area. And they see nearly 800 tornadoes form every year. Next, we have hurricanes, which we're all familiar with here in North Carolina. These hurricanes are really big, so they're huge storms. They stretch across 600 kilometers, right? They're bigger than several states put together. And they can have fast winds depending on the strength of the storm. In order for hurricanes to form, they have to have warm ocean water. So that's why hurricane season is typically, it amps up really good in like August, September, because that's when the ocean is the warmest. So it needs warm ocean water to give it strength to get going. It forms in the Atlantic, Pacific, or Indian Oceans. And it's a huge rotating storm that forms once again around low pressure. Hurricanes form over warm ocean water as a low pressure system. They can bring winds, rains, large waves that cause flooding. This picture here was Hurricane Floyd coming in. It hit North Carolina pretty hard. And the whole way that hurricanes form is whenever that warm ocean water is amping up and providing energy for the storms to start occurring. It causes a lot of evaporation from the oceans, which brings really humid air, lots of clouds, right? So those winds then start coming together, forcing upward, making the storm clouds, and that's when you get your hurricane. The next type of storm is a winter storm. These are associated with, once again, a cold front. These occur during cooler temperature times. They produce high winds, low temperatures, and frozen precipitation. So winter storms can get dangerous whenever you have accumulation on power lines or something like that, and the wind blows, cracks the power lines, power goes out. Also, especially areas like North Carolina, where we're not super prepared for crazy winters. So whenever we do see a little bit of winter storm action, it gets kind of chaotic because we don't have the necessary things for our roads and safety measures put in place to really help in those situations. So this is actually that really crazy picture that got surfaced that last snowstorm we had a couple of years ago. So this is actually a visual from a snowstorm in North Carolina. So you can see in this visual up here, if it's warm out, it's just rain. As it gets colder, it can turn into freezing rain. Cooler, even more temperature, sleet, and the coldest is snow. Next, we have precipitation, and we all know that precipitation can be rain, snow, sleet, or hail. Okay, it occurs year-round in all areas of the world. It always starts in the cloud as snow and then melts as it reaches your warmer temperatures, because you know where it forms at, it's cold. So if it's warmer down near the surface, it turns into rain. Precipitation will remain as snow if your air temperatures are colder than 0 degrees Celsius, though. And that is it for your recorded lesson for today. If you have any questions, please see your teacher and we will help you.